Okay, so the product rule, if I have the product of two functions, it's kind of like they take turns. It's like a seesaw. They take turns going on a seesaw. So it's the derivative of the first times the second plus the first times the derivative of the second. And you can write it in any order you want. I tend to go with this rule because I like it. So if I'm finding the derivative of this h of x, here's my first function, here's my second function. So they're gonna take turns. So the derivative of h would be the derivative of the first. So that would be 3 minus 4x times the second unchanged plus the derivative of the second. Well, that would just be a 4 times the first unchanged. That's the way I tend to do it. So they take turns. So we take the derivative of the first one times the second one unchanged and so forth. Now, a lot of times this will be simplified out. So this would be 15 plus 12x minus 20x minus 16x squared plus 12x minus 8x squared, which would give me negative 24x squared. So that would be, see, 24x minus 20, that's 4x plus 15. Now, you might ask yourself, do we have to use the product rule for that example? The answer is no. I could have distributed h of x and got that h of x was 3x times 5, so 15x plus 12x squared minus 10x squared minus 8x cubed. So that would have been negative 8x cubed plus 2x squared plus 15x. So if I distributed it at the beginning, then all I'm using is the power rule. And that would be negative 24x squared plus 4x plus 15. So I got the same answer. But a lot of times this way is faster. And let me show you when. So x times sine x, can I distribute that? Well, no. So the first is the x, and sine x is the second function. So the derivative of the first would be 1 times the second unchanged, plus the derivative of the second, well, that's cosine x, times the first. Now, I don't like leaving it like that because, oops, that should be sine x. Some people might think that's x times x there. So I would write it with that x in front of the cosine, so people know it's x times cosine x. This next one, I have e to the x times x. So the derivative of e to the x is e to the x times x, plus the derivative of x times e to the x. Ooh, so we've got a product rule minus something else. So here's our product. The derivative of the first is 2 times the second unchanged, plus the derivative of the second times the first unchanged, minus 2 times the derivative of sine, so 2 cosine x. Oh, wait, that looks cool. Those two cancel. So I get h prime of x equals negative 2x sine x. Okay. Product, x squared times ln x. So the derivative would be the derivative of the first times the second unchanged, plus the derivative of the second times the first unchanged. And I could simplify that if I wanted to. For time's sake, I am not. The next example is using the product rule from a table of values. So this gets kind of interesting. So we've got the values of f prime and g prime along with f and g of x. So if I'm finding the derivative of h and it's the product of f and g, then h prime would be the derivative of f times g of x plus the derivative of g of x times f of x. And we're plugging in 3. So all I'm really doing is looking at the table and finding f prime of 3. So here's 3. There's the f prime column. That's an 8. G of 3 is -4. G prime of 3 is -4. And f of 3 is 1. So that'd be -32 minus 4, -36. Ooh, what about this one? Oh, no, they didn't give us g. They gave us a different one, a square root of x. So just a reminder, that's really x to the 1/2. So when I take the derivative of that, I'd have 1/2 x to the -1/2 times f of x plus f prime of x times the square root of x. Okay, now remind, this is really 1/2 square root of x. Okay. And we're evaluating this when x is 4. So the square root of 4 is 2, so this is 1/4. F of 4 is 10. And then f prime of 4 is -1. And the square root of 4 is 2. So I get, this would be 5/2 minus 2. That's really 2.5 minus 2. This would just be 1/2.